So let me just explain this in words that all right, let's go to the next part. Bismillahirrahmanirrahim. So now we have seen both intuitively and formally that a line has exactly one root. And we understand why, because line goes from minus infinity to infinity and it has to take the intermediate value. But now, okay, so that's our intuition. But how to make it formal? That's a separate. So this is the fast system understanding. You see the picture of the line, you see the axis, you see that they must collide. There is no way that that line can get from bottom to top without passing through the zero. That's the intuition, that's the theorem. Now how to make it formal, how to prove this thing? Well, that's the slow system, how to express it in logic, 1, 2, 3, 4. That's a different methodology. So that's so one of the difficult things is how to define a continuous function. Okay, so this is the intermediate value theorem. In general, there are two things. There is the value a here, which is at the start, and b here. Now the function takes the value f of a, which is the first green line here, and then it takes the value f of b, which is here, and then the intermediate value says that all values in the middle the function will take. So here y equals u is one value, and actually the function takes this value at 3 different points. And basically there is no way that it can miss. So now what is the continuous function? Well, the formal definition is rather difficult, but the informal definition is the idea that the continuous function is has a graph which you can draw without lifting your pencil from paper. So again, that's a intuitive understanding. So why must a line have at least one root? Well, we know that we've already explained that, but formally, if you want to fit it into the slow system, then you say that, okay, the slope is not 0 by definition because it's first degree. So now it has to be either positive or negative. Now we are working slow system, case by case, logical. So now there are two cases. A is greater than 0. And when you are using fast system, this just flashes in front of you. You can visualize the line with this slope and with the negative slope and see that both cases work the same, and you don't have to break it out. When you use slow system, you have to take it step by step, logically, one step at a time. So if a is greater than 0, then we go by logic y equals ax plus b. This is the standard positive slope. So y must the line must be minus infinity at x equals minus infinity, and it must be plus infinity at positive infinity. It must pass through 0. If a is negative, then the same thing applies in reverse. You start at plus infinity, you go to minus infinity. Again, you must pass through 0. And then there is in the middle we use again another intuitive idea that lines are continuous. If the line was not continuous, then this would not hold. Okay, so basically, again, a formal definition of continuity is quite difficult, but understanding the concept is very easy. Oh, one very important method for understanding a concept is to try to formulate its opposite. So if you want to understand continuity, think about what it means to be not continuous. So this is a signum function. The signum function takes the value, is the sign function. For negative values, it takes the value minus 1. For positive value, it takes the value plus 1. And for 0, it doesn't have a sign, so it's the value 0. It is pictured in the red in this graph. So for all negative values, it takes value minus 1. For all positive values, it takes value plus 1. And at 0 exactly, it is 0. So now this function goes from minus 1 to plus 1, but it does not pass through all the values in the middle because it has a discontinuity. So we understand that the intermediate value theorem works because of continuity. If the lines had jumps, then it would not work. So actually now this makes it even more difficult to make it formal. When you try to make this formal, then you see that you have to understand what is the real line. Now the real line is right there in front of you, but when you try to explain what a real line is in algebra, you run into severe, enormous difficulties. So even now there is work going on how to define continuity. So interestingly, people apply intuition. So there is this famous Black-Scholes theorem. It tells us in the financial market how to price an option. An option is something that you can that will allow us to purchase a stock. So if there is an option at $100, so suppose that there is a stock. What it is used for is, suppose that I want to buy dollars, but I will be suppose that I am making an export, and I will be getting the price in dollars, and from the dollars I will be converting to rupees. But I want to make sure that today the price of rupees is 105. I want to make sure that the price of rupees does not go down to 200, for example, because when I receive my money, price of money, dollar doesn't appreciate. So rupee doesn't go from 110 to 100, for example. So I can buy an option which says that on 6 months from now, when I have made the sale and I have dollars, this option will enable me to purchase rupees at 110, even if the price has gone down. Now, if the value of the rupees is 110 or more, this option is worthless. Yes. Because, but if the value of the rupee is worth less, the option is valuable because it enables me to buy at 110, even though actually if I sold on the market, I would get less rupees. So now this option can be, it itself has a price. The price could be 10 rupees, or and when some company can issue me this option. So the Black-Scholes formula is a way to put a price on this option. Now this Black-Scholes formula assumes that the price of the stock will move in a continuous fashion. But near the global financial crisis, people realized that the prices were going to move discontinuously. Some people sitting in a garage, these people who invented the Black-Scholes formula, they were deceived by the beauty of mathematics, and they applied it to the stock market. These people sitting in the garage, and they got a Nobel Prize, the people who invented this Black-Scholes formula. But these people sitting in a garage with minimum education, they tried to understand that these options, they said that, the market is going to collapse, and if I am able to buy this, if I am able to buy insurance against this collapse, it will be worth a lot. So, but actually purchasing what is called a short sale was quite difficult and expensive. So they bought themselves an option. Option was very cheap, and they tried to figure out why the option is so cheap, because they saw that it's almost clear that this stock is going to collapse and this is going to be worth a lot. So it was because people were using the Black-Scholes formula, and they studied it, and they figured out that the assumptions are wrong. They are not matched to this market. So basically, what I'm trying to say is that having an intuitive understanding is worth a lot more than Nobel Prize level mathematics. And people sitting in a garage can have an intuitive understanding which enabled them to make millions. And actually part of the reason why the collapse occurred is because these people were betting heavily against on the collapse. And so this was also part of the contributing factor in the collapse. But basically, some very smart guys with doing heavy-duty formal mathematics, but without any intuition into the workings of the market, came up with these formulas and theories, which are all wrong. And somebody who has an intuition into how things work can beat the formal mathematics. Okay, so I think we end here. So next time I will start with the study of the quadratic equation, which will take us to Al-Khwarizmi, because that's the one who solved the quadratic equation. But you have never studied quadratic equation in the way that I will be teaching, inshallah.